Hi everyone and welcome. In this video I'm going to be talking about amplifiers. So to start with, what is an amplifier? Well, an amplifier is something which basically magnifies or amplifies a voltage. So it gets a voltage and it makes it bigger. Put very simply, that's what an amplifier is. But why would you want that? Well, in the case of microcontrollers, or particularly the Arduino, it has an ADC, and the ADC ranges from 0 to 5 volts, usually. So 0 to 5 volts, and it also ranges from 0 to 1024 counts. So for those of you who've worked with the Arduino ADC, you should know what I mean by that. If you poll the ADC and you use analog write, if you use the analog write method, it'll ask you for a pin, and basically it polls the pin and it returns you a value from the ADC. So if you were to put in 5 volts to the pin, it would return 1024, right? Or if you were to input 2.5 volts, it would return 512. Common sense. But if you get that voltage then, divide it by 1024, you'll notice that you get 4.8 millivolts. So sometimes we say 5 millivolts, but it should be 4.8 really. So if we get 5 millivolts into the Arduino, then you'll get 1 count, because 5 millivolts divided by 5 millivolts, or 4.8, is 1. So therefore you get 1 count. So when you use the serial console and you say analog write, it will return count 1, 1, 1, 1, 1. Whereas if you had, if you input say 10 millivolts, it would output 2 counts, and then all the way up to 5 volts, or 1024 counts. Anyway, so why am I saying this? Well, the reason I'm saying this is, well, what happened, or what would happen, if you were working with a voltage less than that? Or let's say you were working with a voltage that was in between 2 counts. So 4.8 millivolts, or 9.6 millivolts, that is basically 1 count and then 2 counts, right? So what happens if we were trying to measure something that's in between? So if that's 0 and 0 millivolts, what happens if we were trying to read a value here or here? What happens if we were trying to read 5 millivolts, or 5.2, or 6, or 7, or whatever? Well, the short answer is you can't. You can't do it because the Arduino doesn't resolve to it. So this is where amplifiers come in. Now, specifically, though, why would we want to do this, and why is this an issue? Well, it's not usually an issue, but if you were to work with something like this, this is a current shunt, or a shunt resistor. You can see here that it says 20 amps, 75 millivolts. And what that means is if you pass 20 amps over the shunt resistor, there will be a voltage drop here of 75 millivolts. And 75 millivolts is the maximum, and 20 amps is the maximum amount of current that's rated for this little device, or this resistor. So we have a problem there, don't we? We can only actually resolve to 15 values, because 75 millivolts divided by 5 is 15, or it should be divided by 4.8, but whatever. 15, so we can only use the first 15 counts of the Arduino ADC, and that's a problem, because it means that we don't have the ability to be very accurate when it comes to measuring. So, now, what's this got to do with it? What it's got to do with it is that if you were to get 75 millivolts and then amplify it to say 5 volts, then we could make use of the full 1024 counts. And if we were able to make use of the 1024 counts, or the full 5 volts, we'd have much, much better accuracy. And what it means is that the 20 amps can be spread all over the 1024 counts, which means that then we can actually determine values that would otherwise be in the middle of here if it wasn't amplified. So yeah, that's basically why you'd want to amplify it. So it would be extremely useful if we were to amplify it, because then we get much better accuracy. And that's basically what an amplifier is and where they're useful. Okay, so let's go in a little bit more depth now. I'm not going to go too mad with this video, by the way. It's only meant to be a beginner video. But let's go a little bit deeper. So if we were to get an amplifier would usually come in a chip or an IC, and they usually have about 8 pins. But what are those pins? So if I just draw a very basic amplifier here, okay, this is a very basic, very crude amplifier, but hopefully it'll be easy. So the first thing, you have an input, I can't remember what it's called now, basically a supply voltage. So let's say we're going to supply this amplifier with some power, and we'll supply it with 5 volts of power, and we've got ground. So up to now we've got 2 pins, so there's a supply and there's ground. So what else? You also need to give it something to amplify. So usually we have a plus and a negative. So if we were to get our shunt resistor here, and we'll just put that there, let's say the current's flowing this way. It's a DC circuit and the current's flowing this way. So this little screw here, I'm going to connect that to the plus, and I'm going to connect this one to the negative. So we've got our voltage drop here, which is, let's just say it's 75 millivolts. In fact, it doesn't really matter what it is, but so we've got our circuit over here. We've got our, let's say we've got our load over here somewhere. So we've got a circuit, 75 millivolt drop. So basically the amplifier is connected to that and connected there. And the resultant output is here, so output. And that goes basically wherever you want it to go. Now, there is a little bit more as well. I'm not going to go into too much depth though, but most amplifiers have something over here as well. I'm not going to go into too much depth with that, but basically the way it works is that it controls the output. It basically modifies the gain. So if I just mark this line here, gain control, and usually that consists of 1 or 2 resistors, and that's a very basic amplifier. So if we were to get 75 millivolts here, 75 millivolts, and let's say we had a gain of 10, then on the output here we'd have an output of 750 millivolts, which is 0.750 volts. And then of course you'd connect the microcontroller to ground as well. So this pin here would go to, say, an analog pin, let's say A0, and this one would go to the Arduino ground. You know, the Arduino ground pin. Actually, it doesn't have to, but ideally. And that's all there is to it. Okay, so that's amplifiers put very simply. So I've gone through what they are, why we need them, where we use them, and then finally a very basic amplifier circuit. So probably in the next video I'll go through actually how to use one practically, how to wire one up and get it to work with the Arduino. It's actually quite tricky, but you'll see.